Hi, everybody, and welcome to today's roundtable discussion addressing corrosion issues affecting the midstream industry, hosted by the Center for Midstream Management and Science at Lamar University in Beaumont, Texas. This webinar is the second of a series focused on the domestic midstream sector. Our first webinar on major issues facing the midstream sector can be found on our website. Just Google Lamar Midstream Center to get there and click on the Events and News tab. Today's distinguished panel are well-versed in corrosion matters in our industry, and we're very proud to have them with us. We have with us today Dirk van Oostendorp. He is Director of Engineering and Technical Services at Corpro, a division of Aegeon, located in Houston. Dirk has more than 40 years of global experience in all aspects of pipeline and structural integrity, encompassing cathodic protection, corrosion control, material selection, protective coatings, inspection technologies, and risk assessment. More recent experience includes integrity monitoring, failure analysis, and pipeline integrity issues. He holds undergraduate and graduate degrees in chemical technology and physical chemistry, is a fellow of the Royal Society of Chemistry, a fellow of the Institute of Corrosion, and an NACE corrosion specialist. Mr. Oostendorp is the author of 22 technical articles and 36 conference papers. Also with us on our panel is Dr. Christian Lederer, Business Development Manager and Refining Corrosion Specialist for Emerson Automation Solutions, also located in Houston. Dr. Lederer began her career in the refining sector and now configures corrosion monitoring solutions and supports Emerson's North American midstream and downstream customer base. Christian holds a PhD in mining and metallurgical sciences and earned a bachelor's and master's degree in process and environmental engineering from the University of Leoben in Austria. She holds an NACE certification as a refining corrosion technologist. Rounding out our panel is Cody Brinson. He's a corrosion technician at Energy Transfer's giant Nederland terminal facility. Cody began his corrosion career with Corpro in 2014 before joining Energy Transfer at the Nederland terminal facility in Southeast Texas. This storage facility is the largest singular owned above ground crude oil storage facility in the United States with substantial pipeline connectivity and waterborne access. Cody is a graduate of Kilgore College with an associate's degree in applied science in corrosion technology, and holds an NACE corrosion certification. This roundtable discussion will last approximately 1 hour, and I expect that we'll have quite a lively discussion on very interesting aspects of corrosion management in our industry. The format of the Q&A will have me directing a question to one of the panelists who will take 2 to 3 minutes to answer, followed by comments and perspective from the other panelists, again with commentary lasting no longer than 2 to 3 minutes per panelist. Ideally, panelists will engage in some back and forth on the discussion as new ideas come up. Cody, the first question is for you. Cody, in midstream construction and operations, what are the primary causes of corrosion and common methods by midstream companies to combat this corrosion? Additionally, what are the weaknesses of these methods and what may be worthwhile investigating to improve field operations in combating corrosion and related integrity risks?
Thank you again for having me on. And first, one of the main issues that we have here at the terminal is we have the FRP pads that they put in between a pipe support and the pipe to keep the pipe support from gouging into the pipe. And one of the many difficulties with those FRP pads is they have to be installed correctly. What it basically is a polymer pad that goes to the bottom of the pipe, and it is installed with epoxy in the middle of it, and then around, and you kind of smush it to the bottom of the pipe. You have to completely seal off those FRP pads so no water or any contaminants can get down in underneath the pipe and start eating away at that coating. The issue is not all of them are installed properly, and the really hard battle is inspection work. So what we're finding is over time, they normally fail, water gets in there and starts eating away the coating and starts causing corrosion. So one thing that we've kind of come up here at the terminal to fight that is we've come up with a new design for our pipe supports where the FRP pad is on the support itself and has little channels to where when water hits it, it goes down in the channels, but also still has that polymer pad. It's made out of a urethane, so it self-lubricates itself with the more weight you put on it. So we're still not causing any damage to the pipe or the coating itself, but we're not causing any corrosion issues at the same time. So that's just one of the issues. Another issue that we're having here at the terminal is we have a lot of our assets are kind of fairly old. We have a lot of internal corrosion. Stuff just gets, used to be crude with just sitting pipes, and over time, bacteria and stuff just starts eating away at the bottom of our pipes, causing small leaks. So what we've come up to combat that is put it on flow schedules. You know, keep the product circulating, keep flow going. That way, doesn't let stuff just sit there and start eating away at the pipe. Another thing that we've kind of looked into in the future, maybe when we start putting brand new pipe in the ground, is to internally coat it with some products. I know Denso makes a product that, you know, they can coat the inside of the pipe, and that is impervious to crude and petroleum products. So that's something that we're kind of looking at into the future to try to kind of combat some of these issues, to instead of being reactive, be more proactive in our corrosion department here.
Okay, Cody, thank you very much. Dirk, do you have some commentary on this?
Absolutely. I'd like to follow on with the comments that Cody made. You know, from our side of the world, supporting a lot of the operators, we see a number of common threads. Some of the aspects that we experience are, you know, the fact that there's external corrosion and internal corrosion. External corrosion when you have something metallic that's exposed to a corrosive environment, and even air, especially along a coastal area where you have a marine type and high humidity, can be corrosive to tanks and pipelines above ground. Internal corrosion, depending on the fluid and operating conditions, there can be corrosive environments internally. So I guess historically what we've seen is a combination of protective coating, some sort of anti-corrosion coating, abrasion resistant coating, in combination with cathodic protection in many cases. In other cases, it'll be chemical treatment in order to manage the corrosivity of the fluids being handled. And unfortunately, a lot of these technologies become passive after a given moment. After they've been installed or applied, they are just operational, and unfortunately, they do require, you know, routine maintenance. They require inspection. So there does have to be a proactive component. It's not just simple enough to install it and leave it operational and expect it's going to perform, because things do change, parameters change, set points change. So, you know, from an overall integrity management standpoint, it's important to sort of shift that into a more proactive mode for inspection purposes, which will then allow repairs, upgrades as needed. And we're also starting to see quite a bit more attention being focused to remote monitoring capabilities where data is being transmitted back on a regular basis. So that's also getting a lot more acceptance in the industry as a means to stay ahead and stay more proactive on the integrity in the battle against corrosion.
Oh, that's good. Hey, Christiane, that's almost a perfect segue over to you in this question.
Well, thank you. So along with what Dirk said and Cody said, we have strategies to mitigate corrosion, right? But the timing and when these mitigation strategies are implemented, we want to also acquire a data set that gives us a baseline of what has been done before, what does the mitigation strategy work, and is it potentially time to exchange facets, to repair, to potentially upgrade. So the segue here is into providing data around the mitigation strategies we implement.
Okay.
Thank you.
Thank you, Christiane. Okay, for the next question, Dirk, this one is coming to you first. Interstate transmission pipelines are regulated by federal regulatory agencies such as the U.S. Department of Transportation. and the Pipeline Hazardous Material Safety Administration. While intrastate pipelines are regulated by state agencies such as the Texas Railroad Commission. That said, for the time being, there are a large number of currently unregulated pipelines in the midstream market, such as gathering and trunk lines. What can operators do to enhance their unregulated asset inspection and integrity management processes today to prepare for broader regulation in the future without spending a lot of money?
Thank you, Tom. That's a very good topic and very relevant at the moment as a result of some changes last year. But I'll take just a moment and give a bit of a historical perspective. Back in 1999, there were a couple of major pipeline accidents that heightened the need to improve pipeline safety and integrity. So the Department of Transportation engaged, and by 2002 had a new set of regulations in place that marked sort of a major shift in pipeline integrity as we know it now. Prior to 2002, operators had a lot more latitude as far as best practices and what they were doing as far as their inspection programs, routine maintenance programs, et cetera. But as of 2002, the Pipeline Safety Act required all operators now to have a written plan wherein they state exactly how they're going to go through the process of maintaining the operational integrity and safety of their pipelines. And it allowed a number of different options as far as how they would go about that, the risk assessment process that goes with that, and then also the delegation of certain authorities. So as you mentioned in the question, ultimate authority for all of pipeline safety in the United States falls under the jurisdiction of the United States Department of Transportation, and specifically their Pipeline and Hazardous Material Safety Administration, PHMSA. That organization has set the bar as the minimum standard across the country, and they are the ones responsible for regulating, inspecting, and auditing all of the interstate pipelines. For the interstate, what they've done is they've delegated authorities down to the states themselves, wherein the state has to meet the federal regulations as a minimum, but can apply additional regulations that maybe are more directed towards local conditions. So for example, in the state of California, because of seismic activity, there can be enhanced requirements in that aspect. If I think about the state of Louisiana, where you have a lot of marshlands and protected waterways, there's increased requirements as far as marine life protection. So everybody has to meet the federal regulations at a minimum, and some of the states have applied some additional regulations. The initial set of rules that were signed into law were mainly focused on transmission pipelines, both liquids and gases. And in that definition, there was also a bit of latitude there. Last fall, in October, a new set of regulations were signed into law. Everybody calls that the mega rule. And one of the implications of that is that the Department of Transportation is now more clearly defined exactly what they mean by gathering pipelines on the production and on the midstream side of the business. So that is going to increase the total mileage of regulated pipelines as a result. And at the same time, the original regulations focused mainly on what they classified as high consequence areas. And the new regulations now also take moderate consequence areas into consideration. So the overview and breadth of that, the regulations has expanded. Based on the experiences that many operators have had over the last 10 years, I think they could protract that out over these additional pipelines, incorporate these new pipelines into their existing management programs without having to go through the process of totally recreating a program for these additional lines. So I think that would be probably the easiest method in an economical manner to get the coverage that they require.
Very good. Thank you, Dirk. Christiane, you have some thoughts on this?
Yes, so particularly what we have been seeing is a requirement for improved monitoring quality, right? So as locations are being monitored, the question of repeatability poses itself. Is there always the same spot in a wall thickness measurement, for example? Is that fluctuation leading to, and what Dirk mentioned, extrapolating out into an end of life scenario, meaning we need more data density and we need more accurate data. repeatability, pose in itself, compensation, of course, too. So data quality is what we have been seeing, and where we think with continuous monitoring, we can get the data density up to where we can then extend our best line of fit into an end-of-life scenario.
Okay, thank you. Cody, what does our onboard inside the fence guy have to say on this?
Kind of the same as what Dirk was saying. When you have these old these pipelines that aren't regulated, or new pipelines that aren't regulated that they become regulated, you can use the practices and remedial work plans that you've used for your regulated pipe to kind of create your plan to go into to make all these things regulated, to keep everything on a schedule for preventative maintenance and stuff, to get it to the exact integrity standards that you've already had your regulated stuff, your regulated assets at, to kind of bring that program over to your non-regulated stuff. It'd make it a lot easier, like Dirk said, instead of starting from scratch.
Okay, thank you, Cody. We're going to the next question now, and Christiane, you're up for this one. Operational integrity is an increasing concern for midstream operators, especially those with old, often greater than 50 years old assets. Over the past year, we have seen many operators shift this responsibility from their operations and maintenance teams to the reliability teams. This change has resulted in a shift in mentality from a maintenance or reactive mindset to a system operability or proactive approach. What can be done to support better analytics and improve operator predictive capabilities when it comes to corrosion control and fitness for service? Also, can you address the impact of asset change of service to operational integrity management that has resulted from recent demand reduction and changes in upstream production dynamics?
Thank you. Yes, so the topic of aging assets is always on the top of our mind. Now, then when we're talking about repurposing and when our economy potentially shifts, especially thinking of 2020, but in the recent years too, when storage facilities are built for a specific service, and then the storage, the fluids, the gases, and then further down into potential capacity changes, we need to address, are we still with the material that our storage capacity is built in? Are we still to the point of asset integrity? Are we still seeing what we want to see in our integrity operating windows, meaning capacity, flow rates, and bringing it back to repurposing? That change of service needs to be addressed. And it is exciting for us to also see the shift away from a reactive loss of containment strategy into how about applying a zero leak strategy as a corporation.
Okay, thank you. Cody, you have some thoughts on this one?
Yes, sir. As far as repurposing, we've had a couple of tanks out here at the tank farm that were, back in the day, they were crude tanks, and then they were just left alone for a while. Well, when the industry kind of shifted more towards the LPG side and kind of a little bit away from our crude, here at the terminal, we repurposed 3 tanks. We went in there, cleaned them, did a full inspection on them, make sure that the integrity of that tank is still there, and then make sure that we had to build a new manifold for it. So also make sure that can the flow rates out of these tanks keep up with natural gasoline, which is what they're in now, products that they're in now. Make sure that everything is okay. What additional EPA standards, environmental changes and stuff when you repurpose these tanks for different products. A lot of different things can change from just from crude to the LPG side, and even if we wanted to repurpose into a chemical side, there's a lot of things that go into that, just the integrity and also the regulations of the product itself. as far as being more more proactive than reactive, that's something, you know, a mindset that we've been trying to be out here at the terminal. You know, back in the day, like Christian's saying, it used to be, you know, a leak containment program. Now it's, you know, have a zero leak containment. You know, it's something that you slowly get in the hearts and minds of your people, you know, and everybody getting out in the field, having a program together, doing periodic inspections, making sure, you know, we have some old equipment that's aging that maybe, you know, is beyond repair. Maybe we need to update it and get it to a way we don't have a catastrophic failure where we're trying to be reactive and get oil out of the ground, stuff like that. So it's good to have these programs in place. That way we can kind of, you know, be on top of our assets even when they start aging.
Thank you, Cody. Dirk, commentary?
Yep, I appreciate the input on both of these points, and it's absolutely on the mark. I mean, if we think about the majority of the pipeline infrastructure in the United States right now, some of the main arteries across the country are 50 years old or older. And if we sort of keep in mind that those pipelines were originally designed for 25 years of operation, I would have to say they've done very well and served us very well. On the backside of that, I think that the teams over the years have done a tremendous job of maintaining those pipelines to keep them operational well beyond their design lifetime. So I think that's important. Looking at it in today's world, the cost of replacement would be astronomical. So there's really no feasible way for us to try to replace these pipelines at some point and do it effectively. So that's going to put more emphasis on further maintaining these existing lines, keeping the operational integrity up to where it needs to be. And this is where we've seen this shift, which is quite encouraging, rather than, let's say, tamping out grass fires as it may have been in the past. It's now looking out ahead. You know, instead of looking at how many leaks were repaired or how much it costs to maintain the facilities, there's a lot more focus on system uptime, and that's the reliability shift. Targets and key performance indicators, KPIs being set that are tied to the reliability of the system, the uptime of the system, and the overall safety, I think, is an interesting shift. Especially when we're going through, you know, the dynamic situation. If we look at the production numbers that are published on a weekly basis and monthly basis as a result of COVID, as a result of crude oil moving around and prices and fluctuations, this massive infrastructure has to absorb those kind of waves as things start and stop. So keeping these systems safe and keeping these systems operating according to design parameters, I think, is critical. And shifting towards a reliability standpoint is great. This points more towards, you know, the predictive diagnostics part and the remote monitoring. So I know we're going to talk about that in a little bit, but I think this is where we're going to be headed more.
Thank you very much, Dirk. Dirk, now stay in the front seat because you've got the next question. Okay, most midstream operators develop their risk assessment for API 580, 581. This approach is based on threat identification and probability of failure, based on past failure statistics per equipment type or class. Some operators have moved to active monitoring as a predictive diagnostic tool. For example, vibration monitoring on pumps. What other operational or process management characteristics could be actively monitored to improve predictive diagnostic capabilities, thereby reducing in-service failures?
Thanks, Tom. Yeah, it is a good follow-on to our previous question. From my background, having spent time in some of Shell's operating companies, the threat assessment was a key part of the overall risk management. And so using API guidelines, 580, 581 is a very good one. There are others in the 570 series. They create a good backdrop and sort of an ideology that can be used when looking at risk assessment, and from there driving it towards a risk-based inspection program. So it involves first looking at the potential threats that are associated with any piece of equipment, whether it's a pipe, a pump, a valve, whatever it may be. Going through industry databases based on reliability that give indications on the probability of failure and then the likelihood. Tying that back to potential operational risks, and then breaking that down by equipment type, class is important because pipelines fail it differently than pumps do. with pumps. Redundancies or capabilities are in there as far as being able to switch over and maintain operations. And once again, the industry has started to move more towards a sort of predictive diagnostic approach there. For example, we're talking about pumps or possibly even turbines, along with things like pressure measurement, temperature measurement. There's also vibration monitoring now where they're used to actually predict the life of, let's say, a shaft or a stem on a valve. Prior to its actual failure, you'll have some time frame where you know what the remaining life of it would be. And that also works back with sparing strategies, where it allows the operators then to have the spare components ready, plan a system outage in order to complete all of the repairs rather than waiting for it actually to fail while operational. So it's staying ahead by being predictive in that sense. Potentially an area where we're starting to see tools along the lines of artificial intelligence and machine learning starting to get involved as well, with all the data that's coming in to look at trending analyses and predict this ahead rather than dealing with something failing in service and potential dangers and safety hazards that can cause.
Okay, very good. Thank you, sir. Christiane?
Yes, so machine learning will be a topic we go on to discuss a little further later. We reassessing and having risk-based inspection programs allows us to then also look at inspection intervals, right? So defining those quote-unquote hotspots, right? Areas of concern that help us in the end implement a zero leak strategy, right? Defining those condition monitoring locations, CMLs, is what we do, and that's exactly where continuous monitoring solutions will be hooking in. That's your idea of, can we and could we have our asset monitored continuously and have a data acquisition rate, an inspection, so to say, interval that it helps us with this condition monitoring locations as process temperatures, flow rates, for example, shift, and how they are affecting our integrity and our asset performance.
Okay, thank you. Cody, do you have some thoughts in this area?
Actually, Dirk and Christiana answered it perfectly. I don't have anything to add.
Fair enough, fair enough. One thing I'll add is that Lamar's College of Engineering has a lot of work and research going on in precisely this area. Deep learning, predictive diagnostic capabilities, it's front and center in what this College of Engineering is working on these days. Okay, the next question, Christiane, you're up front on this one. How does accessibility of corrosion and erosion monitoring locations affect data acquisition? And if there is a data collection problem, what can be done to improve data acquisition?
This ties right back into the question with Dirk, risk-based risk assessments that we are trying to, strategies we're trying to implement, tying them back to how often does an asset have to be inspected, how can we perform asset integrity strategies, meaning how can we tie back data. Now, as and often these locations tend to be in hard to reach, elevated locations, and this is actually the corrosion mechanism is not particularly interested if we can monitor it appropriately, so it happens, and our inspection intervals are sometimes also driven by, are we able to access, right? So potentially building scaffolding. And then thinking back also to our question on repurposing assets, changing the service of an asset. Are we of course, we are reevaluating when we are running a different process fluid, storing different liquids. Are we actually also engaging enough in seeing small changes, variations of process conditions, meaning especially flow rates. All of our corrosion mechanisms tend to have a facet in too low or too high corrosion. That's where we then involve our asset integrity and look at our IOWs, our integrity operating windows. So it is in its design, right? Now, then we come with scaffold, we come into the interesting question of we are trying to implement and having access, not reactive, proactive strategies on our process safety. Now, how does that play into the facet of personal safety, right? Every time we have a hard to reach, elevated location, are we increasing process safety risk over improving our process safety?
Okay, thank you. Cody, do you have a thought on this one?
Sorry. The accessibility of corrosion monitoring. As far as like our remote monitoring, it allows us to kind of have a longer reach, or like for example, our rectifiers. Instead of us physically going in and checking them, periodically, we can now have a remote monitor throughout all of our pipelines and our terminals and things like that, where it can give us notifications if we lose power during a bad storm, if there's a natural disaster of any type, or if anyone just runs into a pole, knocks power out, and stuff like that. As far as here in the terminal, that's something that we've actually made a company standard to have a remote monitoring system to give us a little bit of edge and kind of be a little more proactive instead of waiting to our inspection dates to go inspect our systems. It gives us a little bit of a head of a curve type deal to help monitor our assets.
Okay, Bert, do you have some additional commentary here?
Yeah, this is one of my favorite little topics. I enjoy this one quite a bit. So as a chemist, I always view this as entropy in motion. Corrosion doesn't necessarily occur at the most convenient locations or at the most convenient times. It always sort of picks the worst place at the worst time to actually manifest itself. And this is both corrosion and erosion. And the other really fun thing is that as processes change, flow streams change, conditions change, those locations move around. I can't tell you how many times over the course of my career I've worked with some folks on the production side where they'll tell me that for the last 10 years they had been operating these particular 6 wells and everything was just fine, and then they brought on 2 brand new wells and all of a sudden everything went sour. Or all of a sudden now they're seeing increased erosion on valves. So this is a case where these sort of things happen. They can happen very quickly. Depending on the details, the corrosion and erosion rates can be very, very extensive and lead to failure way in advance of the predictions simply because the conditions have changed in the dynamic sense. So I think what's happened, as both Christian and Cody mentioned, is the types, the size of the monitoring equipment, the capabilities of the monitoring equipment for both corrosion and erosion have greatly improved over the last decade now, to where there's the capabilities with remote monitoring to get the information sent back to permit live trending analysis to be done. Worked with a copper mining company a few years ago and implemented a risk-based inspection strategy together with a predictive monitoring capability where we were able to prevent major blowouts, for example, on some of their slurry pipelines. They were GRP pipe, and a blowout would take typically 15 to 18 days with cleanup and everything to repair. Whereas if we knew this was going to be the case and we're able to change the flow over to the alternate flow path and replace, for example, these piping spools or elbows before they would actually fail in service, it was a 3-day turnaround. So the amount of time saved was massive. because there was this sort of predictive capability and monitoring capability actively looking after the system. So, you know, as you mentioned with machine learning, with the capability of understanding these data streams and using them in a more proactive manner, coupled with the improved data acquisition, this whole area is going to improve to where we can greatly improve the overall system reliability.
Thank you very much, Dirk. Cody, you're up front and center for this next question, the sixth question. Wall thickness measurements are used to monitor pipeline corrosion and erosion. What methods are used to make these measurements, and what are the strengths and weaknesses of these methods? What can be done to improve data quality in the future?
So as far as wall thickness measurements, I know a lot of pipeline companies, they'll do smart pigging. And that's where they get a pig, they launch it in the pig trap, and it travels through the pipeline, and it takes UT or ultrasonic thickness measurements throughout the pipe as it goes through the pipeline and into the pig catcher. The drawback to this is it's very expensive to do, but it does give us a lot of good data. The other way to take a UT measurement would be physically digging it up and using a handheld UT meter, which is not always the most feasible. Like we talked about, you know, some of these pipelines go to very hard to reach areas, and sometimes they get bored 80 to 100 feet below the ground. So it's some of these, it's a lot easier to do the smart pigging aspect of it. And as far as improving data quality, you know, as Dirk mentioned on the last question, you know, the technology is improving. You know, every year it gets better and better. And as technology improves, our data is going to improve, and the capabilities, you know, the new technology is going to come out to give us that extra edge of, you know, being able to monitor these pipelines and assets throughout these facilities and on the midstream side.
Another following question for you. How small of a pipe can you smart pig today?
I'm not 100% sure. I know they've done them in 8-inch pipe. We like going to Motiva, where I've been before, all the way to Sour Lake. They have an 8-inch line that they had that was being able to smart pig. It really depends. If it has a lot of hard reach or a lot of hard bends, it's hard to get a smart pig through those. So not every pipeline is smart piggable. It really depends on the design and the layout of the line. Before that's something that, you know, you kind of talk in a meeting before, you know, see it, you know, the restrictions of the smart pig and stuff like that.
Okay, thank you. Christian, what do you think about this topic?
Yeah, smart pigging is a great technology. Now, the other question just is, how often can it be done, and what downtime restrictions will we have here? So the question always poses itself, is there a benefit to having continuous monitoring? Something you can do every day, every week, every month, without a pig being implemented, and then also introducing downtime to the asset. Now, the question always then also comes back to, what is the sensitivity we want to look at, right? How sensitive do we want to record data? And also, what has to be reported back to our authorities? So that's the few key questions, and then picking and choosing the technology. And very often, and as the system is a closed system when it is in process, we benefit tremendously from having more than one variable. So having the chance to have several different inspection / asset integrity monitoring technologies together gives us a fuller picture of a closed system that we can't internally inspect on a day-to-day basis.
Okay, thank you. Dirk, thoughts?
Thank you, Tom. So wall thickness measurement affects the mechanical containment calculations and determination assessment of a pipeline or tank. And so the the accuracy of that data is critical in that sense. If we think about inline inspection, it's been with us many years, and the original generations were all based on magnetic flux leakage, which, if we're honest about it from a scientific standpoint, is inferred data. The tool would magnetize the pipe, you would measure the remaining magnetic flux fields and infer from that the thickness of the pipe. And so things like the cleanliness of the pipe, the coating, coating corrosion product could all affect the accuracy. And it was for this reason that operators would then go out and conduct verification validation digs to determine the actual corrosion present as detected by the pig itself. UT technology was introduced into the pipeline inspection world on the pigging side. Unfortunately, it was very expensive initially, but now as technology there is improved, sensor technology and transducers have gotten smaller and more accurate. That technology has also become more affordable and accessible to the industry. So I think in that sense, a tremendous amount of work has been done to improve the latest generation of magnetic flux leakage pigs. At the same time, there's now ultrasonic tools that are available. You mentioned sizing. There are several companies that have worked on that aspect as well. And as Cody said, you know, it depends on the geometry and the radius of bends and other physical features in there. But I believe there is capability down to 4-inch size right now, but not in the conventional method where it's pushed through by product, but it actually has to be drawn through the line with a tether of some sorts. So we're going smaller, we're going more accurate. There's more economical when it comes to running ultrasonic tools in there. And if we think about like on the water pipeline world also for a moment, the smart ball technology that was introduced a few years back, which is something radically different. So, you know, there have been tremendous advances that have been done there. And once again, it's all about the data quality, the accuracy of the information that's being provided that's used to assess the operational conditions of a pipeline or a tank that provide that information. So accuracy and quality of the data, absolutely critical. But then taking that data and turning it into information and then being able to transform that into action, I think is where we're really cutting down the timeline and will continue to do so.
Okay, thank you, Dirk. Dirk, you're up for the first guy for front seat in this next question. Many midstream companies have operated with lean operations teams in recent years, and some have reduced staff in 2020 in response to market conditions. What ideas should be considered by midstream companies to make sure that operational integrity and safety are not compromised in these tough economic times?
That's a very good question and a relevant one. I mean, again, 2020 is here with us. The impacts of what we call a double headwind, the combination of the fluctuations in the oil prices earlier this year, combined with COVID, have really put everything into a spin. There's been quite a few cutbacks on personnel, reductions in force. One of the big concerns there is the experience factor that may be lost in some of these. Having gone through a few of these in my days with shell organizations, we saw some very experienced people being incentivized to leave the business, and with them went a tremendous amount of knowledge. So I think one of the things that needs to be addressed is how to keep that knowledge in the business and also be able to sort of multiplex it out through the organization so more people have availability to it. And this lends itself more than to sort of electronic and data-driven systems where the information that doesn't necessarily reside in the gray matter at some subject matter expert, but may actually be available on a server system for other people to query and use as well. So as you know, the staffs are cut back or maintained at current levels, the amount of activities that they're going to be expected to perform are going to increase in order to keep an eye on the overall operational asset base. And this is, I think, again, where the speed and quality of monitoring systems and data acquisition systems are going to become critical. The backside to that, I think, is the important piece as well. You know, when you have a mountain of data, what do you do with it? And where do you find the important pieces of information inside all of that data that's not just noise. That's where the analytics, I think, are going to step forward and become front and center in that overall process and helping us be able to reduce that down into actual action plans.
Thank you. Cody, thoughts?
Yes, sir. Just touch a little bit on what Dirk said. You know, as we do reduction of force at these facilities and pipelines, you know, like, you know, our the people that stay on, their responsibilities grow and increase. You know, we need to make sure that everyone stays safe. You know, even though you have more responsibility, just take it one piece at a time. You know, even if you have a mountain of data, take it a little piece at a time and just decipher what is noise and what isn't, and use that to better help your assets. But the main thing is to keep everyone safe, and that way we go home the same way we came in. You know, even with harder times, you know, people aren't, especially 2020, people aren't always thinking about being safe at work. They're thinking, how am I gonna, you know, stay afloat with everything at the house, or, you know. So that's one thing that, you know, you want to keep in the hearts and minds of your folks is, even, you know, when morale's down, you want to keep in their heads, you know, let's finish 2020 strong and hope, you know, it picks back up in the future.
Okay, very good, thanks. Christiana?
Yes, so it's a little also back to the personal safety question, right? And we are trying to collect actionable information. We must start at collecting data that has the sensitivity we are looking for, but also the data quality. So it plays all together. Instead of sending someone up the tower or along the pipeline to do manual tasks, the question is, couldn't this person be better, have a better balance on the exact increased responsibility here of having monitors, having something mounted in the field, reporting back. The responsibility doesn't go down, but we can make our personnel safe without doing these manual tasks. And we can also allow data quality to come back to where it becomes actionable data.
Thank you very much, Christian. Okay, we'll move on to the eighth question, the eighth and final question for the day. And Christiana, you're going to be in the first seat on this one. Now, the question is, more and more midstream companies are investing in remote monitoring systems and harvesting enormous amounts of data in an effort to improve asset integrity and reduce safety and environmental risks. Is this investment in data collection yielding dividends to industry and meeting expectations, or is it just burying operators under mountains of data that is not easily transformed into actionable information? Imagine this one, huh, Christian? Any suggestions on how to improve the data to actionable information transformation? We were leading up to this in the last couple of questions, but it really begs this question. So.
Yeah, thank you. So let's start with your first question. Does it pay off? Yes, we see in our return on investment calculations that quote unquote outsourcing gathering the information allows us then to have good quality data at the frequency we want it with the sensitivity we want. We can satisfy monitoring requirements, mandates out of our authority bodies. We can keep our personnel safe. And then, but we then have this, what has been called an alarm flood, and there are management strategies. It really comes down to a platform question. So making sure that we understand who needs to access the data, what do we want to archive, how can we make this information actionable immediately, and how can we pre-package analytics? And this is exactly where automation solutions can help you. And that's it. It's alarm flood can be managed if you have pre-packaged analytics, and ask the question first, what platform are we on? Who needs the information? Who is collecting it? What is the the connection in between those two parts. That's the field, that's the variable I want to measure. Who needs it, at what quality, at what sensitivity, how often, how do we transfer it into an actionable information?
Okay, thank you, Christian. Dirk, your commentary on this one?
Thanks, Tom. I'll follow right on to exactly what Cristiano was just saying. So Dr. Michael Savoy wrote a really interesting paper a few years back talking about how to build successful information systems. And one of the main parts to that was the structure that he looked at. And he created basically a ladder. And at the bottom of the ladder, you have data. And as you get a few rungs up the ladder, you're going to get to information. As you get a few further up the ladder, you get to knowledge. And when you get to the top, it's wisdom. And I think that's exactly what we're looking at here. There's a massive amount of data that's available to us. Not all of it is relevant. Not all of it is of the quality that we demand. And so we have to find some way to actually sift through all of those data points and information that we have, do some comparison work to validate exactly the value of it before we can actually consider it information. Once it reaches that phase as information, you then have to make the judgment call as to whether or not it's actionable or whether it's just nice to know. And if it is actionable, then that can become that knowledge point where we actually learn something and know exactly what to do next. So I think being able to stage through those different steps is where there's a certain degree of criticality. It's very easy to get buried under data. I mean, if I think about one of the activities that Corpro does quite a bit for our clients is close interval surveys along these pipelines. And basically, we're taking a pipe to soil measurement every 3 feet along these pipelines on a routine basis. And at each one of those points, we're taking both an on and an instant off potential. So if you think about that over the course of 100 miles of pipeline, that is a mountain of data, okay? Taking that down to find out what specific areas along that pipeline are showing any sort of indications is the next step, because there's probably going to be a large portion of the pipeline that's in very good condition and there's no concern. So, you know, it's not that that data is irrelevant, but it's that that data confirms a good condition. What we're looking for are the exceptions, which take us up to the next level. And then, you know, determining, is a dig going to be required, or is there any further monitoring going to be required to turn that into an actionable piece that then fits into an overall plan? And then, what is the frequency that's going to be required? How often do I really need to do this to stay on top of that process based on operating parameters, based on environmental conditions around it? How fast do these things change? That's what's going to drive sort of the reinspection interval requirements on that. So I think this is an area where we're improving. I think this is an area where there's considerable improvement that's still yet to be won.
Okay. Thanks, sir. Cody?
I don't have anything to add. I think Cristiano and Dirk knocked it out of the park on that.
They did do a good job. Well, hey, everybody, that brings us to our final question, and I see our hour is almost up. I want to thank everybody for being here today. The Midstream Center for Management and Science and Lamar University, thank you for your participation, guys. Really appreciate it. To our viewers, we greatly appreciate your attention, and we are hopeful that this roundtable discussion delivered value to you. Be on the lookout for an announcement of our next roundtable discussion addressing current and developing operational issues facing the midstream industry, which we expect to take place early next year.